picture this scenario, right? Because I guarantee almost every single one of you has experienced something like this by now. You are sitting at your desk, maybe it's late at night, and you have this massive project due.
Oh, we have all been there, desperately looking for a quick answer.
Exactly. Or, maybe you are just trying to settle a stubborn debate with a friend over dinner. So you open up your favorite AI chatbot, you type in your question, and within seconds, it spits out this beautifully written, highly confident answer.
Complete with perfectly formatted bullet points.
Oh, always perfectly formatted. It cites its sources. It sounds like an absolute, undeniable authority on the subject. But then, you decide to double-check one of those sources.
Right.
You click the link or you search for the author and you hit a wall.
A classic 404 error.
Yep, a 404 error. You dig a little deeper and the chilling realization washes over you. The AI completely made it up.
Yeah.
It is a fabricated, highly confident lie. And suddenly, you are left staring at the screen wondering, can you actually trust any of these AI outputs?
It's a jarring feeling for sure.
It really is. Welcome to today's deep dive. We are thrilled to have you with us as we unpack a question that is quite literally reshaping how we work, how we learn, and, well, how we process information.
It really is the defining question of this current technological era. I mean, we are rapidly handing over immense amounts of responsibility to these systems.
Yeah, we use them for everything now.
We do. We use them to draft emails, write code, analyze contracts, and even diagnose medical symptoms. Understanding their reliability is no longer just some niche topic for computer scientists in a lab.
No, not at all.
It is a daily functional requirement for everyone.
And to get to the bottom of this, we are pulling from a really wide, fascinating stack of materials today. We are looking at insights from CTO Magazine, some deep financial management analyses from the Credit and Financial Management Review.
Which has some wild statistics, by the way.
Yeah.
Oh, absolutely wild. We're also looking at technical breakdowns on consumer tools like Google and Siri and some incredibly revealing enterprise AI documentation from places like MoveWorks and Skywell Software.
That's a good rate stack.
It is. Our mission today is to cut through the marketing hype. We want to uncover the mechanical reality behind AI risks, understand the actual reason why it hallucinates, and learn how you can navigate its data limitations so you can use it effectively without getting burned.
And I think the fundamental baseline we need to establish right out of the gate is this AI is a transformative, undeniably helpful tool.
Yeah.
But it is not magic.
Right. It's just math.
It is just math.
Okay.
And it is definitely not always correct. If you don't understand the mechanics of how and why it fails, you are basically flying blind.
Okay, let's unpack this. Because
Yeah.
if we want to know if we can genuinely trust AI, we first have to break down the single biggest misconception out there.
The thinking myth.
Yes, the thinking myth. And it's a trap I think we all fall into because the interface is literally designed to feel conversational. There is this pervasive myth that AI thinks, feels, and functions somewhat like the human brain.
Which CTO Magazine explicitly calls out as totally false.
Exactly. We assume that when you type a question, there is a little digital consciousness in the machine, pondering your request, weighing the options, and deciding on an answer.
But the reality is far colder than that. It operates purely on algorithms and data. There's zero humanity, zero consciousness, and, well, zero actual comprehension happening.
None at all.
We project humanity onto it because it speaks our language, but it really helps to look at the architectural difference between what we have now and what we see in science fiction.
Right, like the Terminators or HAL 9000.
Yeah, exactly. The theoretical concept you see in movies, a machine with self-awareness, emotions, and the ability to learn and reason across any domain. The Quick Reference Guide calls that general AI, or strong AI.
And that doesn't exist yet, right?
No, that simply does not exist. It is entirely fictional right now. Every single AI tool available today, whether it's a massive chatbot, a recommendation algorithm on your streaming service, or the voice assistant in your car, is narrow AI.
Meaning it operates within a strictly limited context.
Precisely. It is essentially a highly specialized tool designed to perform a specific task, not a sentient being.
But here is the rub. If it's just narrow AI, if it's really just math and algorithms, why does it feel so incredibly smart?
Yes, the million-dollar question.
I mean, if it is essentially just predicting words like a highly advanced version of the autocomplete on your smartphone keyboard, why does it feel so human when I am talking to it?
What's fascinating here is that the illusion of intelligence comes entirely from scale.
Scale.
Yeah, it comes from the sheer incomprehensible volume of the data it has been trained on, not from any underlying semantic understanding. The MoveWorks documentation provides a brilliant, highly descriptive term for this phenomena. They call it the stochastic parrot.
The stochastic parrot, I have to say that paints quite a picture.
It really does. Hey, stochastic is a mathematical term. It basically refers to a randomly determined process that can be analyzed statistically, but maybe not predicted precisely.
Okay, so it's about probabilities.
Exactly. So when we call a large language model a stochastic parrot, we are saying these massive neural networks are essentially acting as statistical mimics.
They're just copying us.
Right. They mimic human linguistic structures, tone, and vocabulary because they have ingested and analyzed billions of pages of text from the internet, but they lack any true foundational comprehension of the words they are generating.
I want to break down how that actually works in practice, because one of the enterprise examples illustrates this perfectly.
The Paris example.
Yes, the Paris example. Imagine you feed an AI model a training document that explicitly says Paris is the capital of France.
Okay.
Because it has ingested that string of text, it can parrot that exact phrase back to you perfectly if you prompt it.
Right. It knows those words go together.
But if that model doesn't have enough contextual diversity in its broader training data, if it hasn't seen the relationship explained from multiple angles, it might completely struggle to logically deduce the reverse.
Which seems so simple to us.
Exactly. If you ask it, what country is Paris the capital of, it might stumble.
Because it doesn't actually know what a city or a country is. It doesn't have a geographical map in its code, and it doesn't understand the political concept of a capital.
It's just looking at tokens.
Yes. It simply knows that the token for Paris and the token for France frequently appear next to each other in a specific mathematical probability.
So it's essentially generating a well-tuned probabilistic word salad.
Word salad is a great way to put it.
It's looking at the prompt you typed, converting your words into numbers, and then calculating, based on billions of previous examples, what the most statistically likely next word should be. It is predicting the next word, and then the next word, and then the next word in real time.
It is a statistical parlor trick. A brilliant, highly useful, revolutionary parlor trick, but a trick nonetheless.
Yeah.
And when you strip away the conversational interface and realize it is just predicting the next most likely token based on historical patterns, a massive vulnerability becomes obvious.
The data.
The data. Its entire output relies completely, 100%, on the data it was fed during training. It does not possess an internal logic engine or a common-sense filter to fact-check itself.
Which brings us right to the danger of the data itself. If the AI is just a parrot mimicking its training data, then the old computer science adage is more relevant than ever. Garbage in, garbage out.
Absolutely.
There is a massive misconception in the corporate world that, more data means better AI. The idea that if we just scrape the entire internet and feed it to the machine, it will become an oracle.
That is the exact trap many organizations fall into. The reality, and CTO Magazine hammers this home, is that data quality entirely trumps data quantity.
Quality over quantity.
Always. If you feed an AI a massive data set filled with grammatical errors, contradictory information, and toxic language, you do not get a smart AI. You just get a highly efficient, highly confident, error-producing machine.
And it's a black box, right?
Oh, entirely. The quick reference guide highlights this. These deep learning neural networks function as a black box. They are so complex that even the developers who built them struggle to explain exactly how they arrive at a specific decision.
Which is terrifying if you think about it.
It is. That's why there's this massive push right now for explainable AI or XAI. We need to know how these systems are reaching their conclusions.
Wait, I am trying to wrap my head around this. Isn't the whole selling point of modern artificial intelligence that it can process massive, messy, unstructured amounts of data better than a human ever could?
That is the sales pitch, yes.
We use it to find patterns in chaos, so why would more data suddenly be a liability?
I guess, well, if I think about it, it's kind of like a mirror. You hold it up, and it just reflects whatever's standing in front of it. The mirror analogy is the perfect way to visualize it. Yes, it has the computational power to process the chaos, but it does not have the judgment to filter the chaos.
Oh, I see.
If you hold a mirror up to a society that has historical flaws, messy records, and biased data, the mirror does not magically clean up the image. It reflects all of that messy reality right back at you.
And we can actually see this playing out mechanically in historical examples. Take the compass system.
Right, that's a very famous case.
It was an algorithmic tool used years ago in the criminal justice system to predict the likelihood of recidivism, meaning the likelihood that someone would reoffend. When researchers analyzed the outputs of that system, they found it exhibited significant racial bias.
But the crucial mechanical takeaway from that case study is how that bias occurred.
Right, because it wasn't intentional?
No, not at all.
Hmm.
The system was not explicitly programmed with prejudice. There wasn't some line of code instructing it to be biased. It was simply a mathematical algorithm fed decades of historical arrest data.
It just looked at the past.
Exactly. Its only function was to find statistical patterns in that input and replicate them. Because the historical data contained real-world systemic biases, the math faithfully reproduced those biases in its predictions. It is a purely mechanical output that proves these algorithms blindly mirror their input.
It is sobering when you realize how fragile the foundation is. And it's not just high-stakes enterprise systems either. We experience the limits of this data processing in our everyday consumer tech.
Oh, definitely.
Think about the voice assistants we've all had on our phones for over a decade. Look at Siri.
Siri is a fascinating case study in the divide between computational power and actual comprehension.
Skywell Software did a great breakdown of this.
They did, because when you ask Siri a question, your phone isn't usually doing the heavy lifting. The audio wave of your voice is beamed up to massive Apple server farms.
Just to understand what I'm saying.
Right. It runs against colossal data sets just to decode your specific accent, the background noise, and the pace of your speech. It takes an astonishing amount of algorithmic muscle just to turn your spoken audio into text.
Right. And yet, despite utilizing server farms that would put early space missions to shame, it still feels incredibly dense sometimes.
Oh, it really does.
I mean, I could say something dripping with sarcasm like, oh, brilliant, another flat tire. This is exactly how I wanted to spend my afternoon. And the AI will cheerfully ask if I want to schedule a calendar event called Enjoy Flat Tire.
It completely misses the intent.
It completely misses it.
Because intent requires semantic understanding. Sarcasm requires you to understand the difference between what a human is stating literally and what they actually desire based on real-world context.
Which a parrot can't do.
Exactly. A stochastic parrot doesn't know what a flat tire feels like. It doesn't know that humans experience frustration when their plans are delayed. It just maps the words you said to a probabilistic response template.
So what does this all mean? If we are dealing with a technology that relies heavily on flawed, messy data, operates purely on statistical mimicry, and fundamentally lacks the ability to understand human intent or basic logic, what happens when we start relying on it for high-stakes work?
We run headfirst into the phenomenon of AI hallucinations.
The confident lies.
Yes, the confident lies. This is the direct, inevitable result of everything we have just discussed.
Yeah.
Because the stochastic parrot's sole directive is to predict the next logical word in a sequence. It hates a vacuum.
It has to answer.
It is designed to generate an answer. If you ask it a highly specific question and it lacks the factual data or the contextual diversity to answer accurately, it doesn't just shrug and say, I don't know.
It essentially plays improv. Its core directive is to keep generating text, so it calculates the most probable sequence of words that looks like a correct answer. It strings together a coherent, grammatically perfect sentence that is entirely disconnected from reality.
It will confidently fabricate historical events, invent mathematical formulas, and, as you mentioned at the start of our deep dive, generate completely fake citations.
The 404 links.
Exactly. It will invent a URL that looks like a real link because it knows URLs usually start with HTTP and contain words related to your prompt, but the website doesn't exist. And the most dangerous part is that it delivers these hallucinations with the exact same authoritative, confident tone it uses when telling the truth.
Which is terrifying if you are a professional using this to draft a legal document or a student researching a paper or a business trying to automate customer support.
The MoveWorks documentation explicitly warns against this.
What do they say?
They warn that deploying a flaky, unconstrained language model, a flaky stochastic parrot without rigorous guardrails, is a recipe for an absolute public relations nightmare.
I can imagine.
Imagine a company plugging a massive language model into their customer service portal, and the AI confidently invents a fake return policy or offers a massive discount that doesn't exist, simply because it predicted those words sounded helpful to the customer.
Or it generates toxic text based on bad training data.
Exactly. The business implications are staggering, and the financial analyses in our source stack highlight the real-world fallout of ignoring these mechanics.
This is the CFMR data, right?
Yes. There is a staggering statistic circulating in the Credit and Financial Management Review right now. Up to 95% of AI pilot projects in corporate environments fail to produce a measurable return on investment.
Wait, 95%?
95%.
That is an astronomical failure rate for a technology that is dominating every single business headline right now. How is that even possible?
It happens because corporate leaders are falling for the silver bullet fallacy. CTO magazine points this out clearly.
They think it solves everything.
Yes, they treat a probabilistic text generator as if it were a flawless oracle or a general software tool. They assume they can just buy an off-the-shelf AI model, plug it into their messy, unstructured corporate data repository, and suddenly all their operations will be automated.
They think they bought an all-knowing database.
But what they actually bought was a highly creative, statistically driven writer.
Wow. They expect perfection from a system designed to guess. And when the system inevitably guesses wrong, when it hallucinates a critical piece of data in a quarterly report, the project is scrapped.
Exactly. It requires incredibly clean data, careful architectural planning, and seamless integration into broader human workflows. It is never just a magical plug-and-play solution.
Okay, so if the reality is this stark, if the tech is prone to hallucinating confident lies, and if 95% of corporate pilot projects are crashing and burning, how can you, the listener, actually use this in your daily life or your business without courting disaster?
We have to fix the architecture.
Right. How do we solve the hallucination problem mechanically?
The solution runs completely counter to how we usually think about computing power. We usually think that to make a system smarter, we need to give it more access, more freedom, and a wider search radius.
Like, give it the whole internet.
Right. But to fix the stochastic parrot, we actually have to aggressively constrain it. We have to build what the industry refers to as grounded AI.
Here's where it gets really interesting. Because the idea of making something smarter by putting it in a box is fascinating.
It's counterintuitive.
It is. If the fundamental problem is that the AI is pulling from the vast, unverified, contradictory expanse of its entire internet training data, the solution is to take the internet away.
Precisely. You restrict its universe of knowledge. We are seeing this highly effective approach in tools being developed by major tech labs right now.
Like Google Labs.
Yes, instead of using a general chatbot that tries to be an expert on everything from quantum physics to 1990s pop culture, you use a grounded system.
The concept is known as Retrieval Augmented Generation, or REG. The XDA developers article broke this down really well with tools like Google's Notebook LM.
Notebook LM is a perfect example of this.
Because when you sit down to use a grounded tool like that, it doesn't just freely pull from the ether. You upload your own specific, verified documents first. You give it your PDFs, your meeting transcripts, your financial spreadsheets.
And then you apply a strict mechanical constraint. You instruct the model. You are only allowed to synthesize, summarize, and retrieve answers from the text contained in these specific documents.
Do not use outside knowledge. Do not guess.
Exactly.
You are essentially handing the parrot a closed book and saying, only mimic what is written on these pages.
And by doing that, you drastically reduce the hallucination rate.
Because it doesn't have to guess anymore.
Right. When you ask a question, it is no longer trying to probabilistically guess the answer from billions of random internet parameters. It is simply scanning the exact text you provided and summarizing it. It sticks to the true utility of the tool, making your own complex information easier to consume without wandering off and fabricating a lie. If we connect this to the bigger picture, this grounded approach reveals the overarching, critical lesson we need to take away from all these deep dives into AI architecture.
Which is?
Whether you're using it for personal productivity or enterprise deployment, AI must be utilized for augmentation, not replacement.
Augmentation, not replacement.
That is the consensus across Apple Podcasts, Tech Notes, CTO Magazine, MoveWorks, everyone. It is not designed to do your thinking for you. It is designed to handle the heavy lifting of data processing so that you can apply human judgment more effectively.
That changes the entire relationship you have with the interface. It means the human user is still very much the pilot.
The human must always be the pilot. Human validation is the ultimate, irreplaceable safety net. We cannot abdicate our critical thinking responsibilities to a statistical model, no matter how conversational or confident it appears.
Right.
When you shift your mindset and treat the AI not as an infallible expert, but rather as an incredibly fast, highly capable, but, occasionally careless intern, you finally unlock its true value.
That is the perfect analogy. You would never let a brand new intern publish a legal contract or send a mass email to your entire customer base without reading it first, right?
Never. You'd review every word.
The AI can draft the skeleton of a report in seconds. It can summarize a dense 50-page legal document while you grab a coffee. It can help you brainstorm 10 different marketing angles to break through writer's block. But at the end of the day, your name goes on the work. You have to verify the output.
The responsibility of truth still belongs entirely to us. The machine can generate text, but only a human can verify reality.
So to bring all of this together for you, AI is undeniably one of the most incredible tools we have ever built. It can save you countless hours of tedious work, it can distill overwhelming amounts of information, and it can massively boost your daily productivity.
It is genuinely revolutionary.
It is, but you have to see past the conversational illusion. It does not think. It does not possess common sense. It is a probabilistic text generator, a highly advanced stochastic parrot that relies entirely on the quality of its data and the strictness of human oversight.
Trust but verify.
Trust the AI to help you draft, to help you brainstorm, and to help you summarize. But you must verify every single output. Do not let the confident tone fool you into turning off your own brain.
This raises an important question, though.
Oh.
We've established that AI is essentially a highly sophisticated mirror,
Wow.
blindly reflecting the massive data sets of human knowledge, human history, and human communication right back at us.
Yeah.
If that is true, what does our constant, desperate struggle to fix its hallucinations and filter its toxic outputs actually tell us about the digital footprint humanity is leaving behind?
Wow. That is a lot to think about. We are trying to clean up the machine, but the machine is really just showing us ourselves.
Exactly.
Well, on that note, we're going to wrap it up for today. Thank you so much for joining us. Until next time, keep diving deep.